And okay, so we will start now the first, let's say, regular session. And the first paper is Unified Cognitive Architecture for Embodied Intelligent Agents, presented by Pat Langley. This is a joint work with Edward Katz.
Thank you. And thanks to, excuse me, in the AV room, can you put my slides on this? On this? Yes, please. Right. So thanks to Ed Katz, my collaborator on this work, also to Donkyu Choi and Mohad Sridharan, who've given lots of input, and to funding from AFOSR and ONR. So you probably heard of cognitive architectures. They provide a framework for intelligent systems that makes strong theoretical assumptions about the representation of content in the mind and mechanisms that operate on it. Cognitive architectures borrow many ideas from cognitive psychology, including the idea that we store symbol structures, that there are stable long-term memories versus dynamic short-term ones, that things operate in cognitive cycles, and many others. Cognitive architectures always come with distinct modules, but not in the software engineering kind of sense. They almost always access shared memory, operating on the same data structures. And they typically come with some programming language that has a high-level syntax that reflects the theoretical assumptions of the architecture. But most work in cognitive architectures have focused on core mental processes and have not dealt with the interaction with the environment. Let me just say that last bit again. Most work on cognitive architectures focus on core cognition and have not addressed interaction with the environment. So what we want is a framework that lets an agent exhibit goal-directed behavior in the physical world. For example, consider a planetary rover that has to carry out missions in which it delivers sensors to remote target sites, collects samples
Thank you, Pat.
Ken always asks hard questions.
Yeah.
So maybe we can wait and let him go last. No, go ahead, Ken.
Let's see directly we can. Yeah.
And he's going to ask, as he did the first time I gave a talk, why can't I do it all qualitatively?
Well, I'm going to ask, why have you not yet looked at qualitative reasoning for this? If you look, for example, at the use of qualitative representations in World Cup soccer by the TU Graz people, or any of the other citations in the QR book I wrote recently, you'll see plenty of uses for tasks just like this, and you would find it very useful. It seems perverse to not look at that literature.
I do believe that, sorry, I do believe that there are things we could do without doing full mental simulation with, say, numeric estimates. I think there are other cases where we could do it purely qualitatively, but I also believe there are cases where you do need some kind of numeric processing to figure out how long something's going to take.
When you look at that literature, one of the things you'll see that they say is you use qualitative reasoning to propose what the big space of alternatives are, and you need numerical to actually nail stuff down. And that's been something that people have figured out over the last several decades.
Well,
and it's been deployed in physical robots.
Well, I claim that we actually, I claim that we are doing that. I just didn't pitch it that way. So whenever the system retrieves, when it generates, when it's figuring out how to extend a motion plan or how to extend a task plan, it is doing qualitative reasoning over discrete representations, but it's using simulation to evaluate them. So it's not it's a bunch of things it's not generating. But I believe we could do more, and maybe you can tell me off in the break.
Just look at the spatial reasoning chapters and the qualitative representations book.
All right,
and
thank you.
See it laid out.
Okay, thank you.
Thank you.
Yeah, I hope this will be easier.
Yeah.
Does it have to fully plan every element, or can it fully plan the bit that it's doing now and then perhaps defer more details planning to a later time to allow it to cope with larger problems?
The planning process is certainly piecemeal, incremental, so it doesn't. We could implement the system to start executing a plan before it's done, but that can be dangerous. So if what you mean is that could we extend the architecture to generate abstract plans, not until we have some kind of hierarchical representation of skills. And I've done in an older architecture that we developed about 20 years ago, Icarus, we had that. But Icarus didn't have a very good, didn't really have a task planner. So there were problems. I certainly want to go back and put that in. And once we've got that, then we could do what you're talking about. Sure. Okay. By the way, most work on HTNs doesn't really use the hierarchical decompositions to do what you're talking about, right? They generate complete plans anyway, but you certainly could. Yes.
So I think you alluded to the fact that you don't have uncertainty right now, but you plan on going in that direction. I'm assuming that includes occlusion in your visual scene. So let's say you were going to O2 and there was an obstacle. You can't quite see the end of the path, but you generate a plan to go around the corner where O2 is located. And when you make that corner, now you see there's a swimming pool there with Pat Langley drowning. Do you consider that an obstacle to go around to get to O2, or do you generate a new goal to throw you a life jacket?
So in previous papers on PUG in 2016, 2017, the system was definitely generating new goals as it went along. It was using motives to do that. I haven't tested that out in this current version. Certainly in principle, we could do that. We had extended runs where we had a version that integrated planning with execution. It would generate a plan. It would then start to execute it. And if what it perceives diverged from what it expected, then it would change things, and it could even introduce new goals. If it came across a new in this domain, a new target site, which is something it could deliver a sensor to, it would create a goal to do that. Yes. Yes. But what we did not do was sophisticated reasoning about what you did not observe. It's just when it observed new things, it would update its plan. That's certainly, you can do that in some contexts. Sometimes you really want to reason about what's not visible. And for that, I would go after, so I've done separate work on abductive inference that I would try and adapt, but that's a different talk.
Okay, so thank you very much, Pat. That is,
Here.
we can go ahead with the second talk of the session, which concerns aspects about self-control. So the title is Self-Control on the Path Toward Artificial Moral Agency. The presenter is